Okay, so here we are with the extra free response questions, number 8 right here. Says, here's an experiment, determine the rate law. So hopefully my math holds up here. I compared experiment 2 to experiment 1, 2 to 1. And so my HgCl did not change, but my oxalate ion did. And so 0.3 compared to 0.15 raised to the x power has to equal the rate, notice the 10 to the negative fifth cancel, of 2 to 1. So running this through the calculator ends up being 2. This ends up being 4. Therefore, x has got to be equal to 2. So for the C2O4 negative 2 oxalate ion, we're going to have a second order. Then, comparing two other ones, I took 2 and compared it to 3, because you can see that oxalate has held constant there. And so here's 2 to 3, and then here is the initial rate divided by the initial rate. Notice I just dropped the times 10 to the negative fifths. So this ends up being 2, this ends up being 2 to the y power, y's got to be 1. And so for the HgCl2 concentration, you got to have a power of 1. So putting it all together, here's the rate law. Rate is equal to K, HgCl to the first power, C2O4 to the second power. Part B, calculate the value of the rate constant K. So the rate constant K then could be calculated by taking this and plugging in any one of these experiments. I chose experiment number 1. And so I put in the initial rate, 1.8 times 10 to the negative fifth. Here's K. Here's the initial concentration of HgCl2 to the first power. And here's the initial concentration of C2O4, negative 2, to the second power. Okay, here's where I hope my math held up. I took these two to the other side over here, squared this animal, divide that, and I got K to be 0.00762. My units, of course, would be molarity per second divided by molarity to the third power. And then the molarities, of course, end up canceling, and so I end up with 1 over seconds times molarity squared. So there's part B. Then part C ends up having us finding experiment 4 and predicting its initial rate. So we need to use this information from here to help calculate that, because we know that the rate law is equal to K, concentration of HgCl2 to the first power, times C2O4 negative 2 to the second power. And so we want to find this rate right here. We do know that K is equal to this 0.00762, 1 over seconds times molarity squared, times the concentration of HgCl2 in this particular experiment, which is 0.0025 molarity, times the concentration of C2O4 at 0.045, and that would be molarity once again, but don't forget you have to square that. So on my calculator, I'm going to start from this end and put 0.045, square that, and then I'm going to multiply that times my 0.0025, and then I'm going to take that and multiply that times my 0.00762. And when I multiply those guys together, that should be my rate. And so my rate is 3.86 times 10 to the negative 8th. And let's check my units. Molarity squared cancels with molarity squared, so I've got molarity per second right here, which are units of the initial rate. That's number 8.